Okay, let us discuss this problem. So this is an easy problem. So question says we have a rod AB of mass 3m and length 2l. So let us make the diagram. So there is a rod. I think you are able to see this one. Yeah. Now we have a rod. This rod is basically fixed at this point, pivoted at this point so that rod can rotate, and rod has a length of 2l and mass of this rod is 3m, and this can rotate freely about this axis. So there is a axis, this rod can rotate about this axis. Now this says there is a mass m attached to the end B, so this is, he is calling this the end A, and there is a mass m that is attached to end B. So end B there is a mass m. Now it says when the rod is hanging in equilibrium, it is said with angular velocity omega that is given as under root kg by L. So this rod is given an angular velocity omega, let us say in this direction, and the omega is under root kg by L. Are you getting? And now he is giving you, if the value of k is 2, so first part of the question says if k is 2, find the height of B above the level A when the rod first comes to rest. Now this means this rod is moving. After some time, let us say this is the position of rod. It will be somewhere here. Initially I think, let us make this kind of diagram. So initially rod was here. So initial position of the rod is something like this. Are you getting? Now this is here. Let us say this angle is rotated theta. Now we have to find what is the maximum theta. So theta is what? When the rod just comes to rest, this means omega becomes 0. If rod is coming to rest, this means omega is 0. Are you getting or not? So how can we find? We can apply the energy conservation and then we can find omega, because this is a case of pure rotation. About this axis, this rod is in pure rotation. Are you getting or not? So first point, let us find moment of inertia of this rod plus mass about this axis. So let us say call this as A. So I want to find what is the moment of inertia of system about A. Please keep writing. So for this mass I will have m, and what is the length? So this length is 2l, so ml square, plus this mass, so mass is 3m. Are you getting? And now I know about this axis, moment of inertia of a rod is ml square by 3. So m, L is 2l, L square by 3. So this will come out, 3 goes out, so we will have 4 ml, so 8 ml. So we will have 8 ml square. This is the moment of inertia about A. To find out the theta, let us apply energy conservation. So what is the total energy we have at this point? So when the system is here, so let us say potential energy plus kinetic energy. So initial, what is the total energy? So initially, energy we have, kinetic energy half I omega square. Half I omega is given under root kg by L and k is 2, so 2g by L. So I can write 2g by L whole square. So this is the initial angular velocity, half I omega square, plus let us say this is my zero potential energy. So this mass is here, so mass, the potential energy due to this mass is 0. Now rod will have a potential energy, total rod length is 2l. So I can say the center of mass of rod is initially here, there is distance L above. Total length is 2l, so this is L above. So I can write mass is 3m z into h. H is nothing but L. Now let us say final kinetic energy plus potential energy. So final energy I can write. In this case, finally the half I omega square will be 0, because omega is 0 finally. Now what is this height? So let us say this mass, what is the height of this mass? So this is 2l, so this is 2l cos theta. So this mass will be 2l minus 2l cos theta. Are you getting or not? So this height is nothing but 2l into 1 minus cos theta. Are you getting? How can you say? So this is 2l, so this is 2l cos theta, initial 2l, so this is 2l minus. So for the smaller mass, I can say potential energy is mgh, and h is nothing but 2l 1 minus cos theta. Are you getting? So this is the potential energy due to the smaller mass. What is the potential energy of the bigger mass? Now bigger mass will be, center of mass will be somewhere here. So if you see, now what is the height of this point above the ground? You see, this height from here to here, this is L. So this is L cos theta. Are you getting? And initially, so from here, what is the height from here? So this height is L cos theta, total height is 2L. From here to here, this height is 2L. So now center of mass height from this point is 2L minus L cos theta. Are you getting? So this is the height of center of mass. So this height is 2L total. And this height is L. So this height is L cos theta. So from the ground, this will be 2L minus L cos theta. So let us put the potential energy is 3m G H. H is nothing but 2L minus L cos theta. Now if I apply the initial energy is equals to final energy, I can solve for theta, and let us put the value half I is 8ml square. Initial energy is equals to final energy. This becomes 2g by L plus 3mgl. This is equals to final energy. So 2mgl 1 minus cos theta. 2mgl. Let us put 2m minus 2mgl cos theta. And 3 into 2 6mgl plus 6mgl. Are you getting? And minus 3mgl cos theta. So this is the final energy. Now if you see, so this term, so 4mgl, so the LL goes out, and 2, so this 2 goes out. So we will have 8mgl, so 8 plus 3, 11mgl, and let us go this side, so I will have 9mgl. Are you getting or not? If you do this calculation, it will have 9mgl. This is equals to, 6mgl also here. So if I subtract 6mgl, I will have only 3mgl. Are you getting? So if you do the calculation, 8 plus 3, 11 minus 2, 9 minus 6, 3. So I will have 3mgl is equals to, now here you will have minus, let us take cos theta common. So 3 minus 2, so minus 3 minus 2 minus 5mgl. Minus 5mgl cos theta. Are you getting? So mgl goes out. So I will have cos theta is equals to minus 3 by 5. So what the minus sign says, this means this angle must be greater than 90, because I am getting an angle of, so this basically minus sign is saying, so let us just copy this one and then we'll write. Those who have not written, please copy. Okay, if something is missing, let us copy from the top. Okay, so what this minus sign says the final system. So let me take the another page. So you keep copying. So this minus sign is suggesting that the final system is something like that is basically greater than 90 degrees. So I have assumed system is less than 90 degree. That is not the case. Basically system has gone to the greater than 90 degrees. So you have situation is something like this. I have assumed this angle is here, but not this is the case. This system has basically gone something like this. That's why theta is coming negative. So cos theta is minus 3 by 5. This suggests me this angle is greater than 90 degree. So if you see, so if you take the total angle, so this for this theta, you have minus 3 by 5. You can find, so the question also asks, what is the maximum height? What is the maximum height reached by the block B? So what is the height reached by block B? So you can find the height reached by the block B. So this is the height. If initially it was here, are you getting? So initially it was here. Now what is the height? So 2L, this is the total height, plus this angle is 2L. If this angle is theta, then this angle is pi minus theta. Are you getting or not? So this is 2L cos pi minus theta. So you will have total height is from ground is equals to 2L, that is this height, plus 2L cos pi minus theta. 2L cos pi minus theta. And everybody knows cos pi minus theta is what? Cos pi minus theta is minus cos theta. So 2L minus 2L cos theta. And the value of cos theta is minus 3 by 5. So if I plug that value, 2L minus 2L, 3 by 5, minus minus plus, I will have. So this becomes, and 5 into 2, 6 plus 5. So what is the value? Calculate this one. So 2L into, so what this value comes out to be. So let us calculate and put this value. So what this value comes out to be. So 10 plus 6, 16L by 5. Are you getting? So this is from ground. So this height from ground. That is the from initial position of B, or you can say from initial position of B. So this height is from initial position of B. Initial position of B. Are you getting? So simple. Now let us discuss the B part. This question also has a B part. Now what this B part says, find the range of value of K for which the particle describes a complete circle. So what will be the value of K? So what is the value of K so that it completes block B completes the circle. That is, this means this whole circle is completed. So now this is here. After some time it will go above and it will reach here. So what is the value of K so that it can complete the whole circle? So now if you want to complete this whole circle, what I will ensure is, initially it was here. Now when it reaches to the top point, its velocity just becomes 0. That is enough. Because this is a rod. In rod you will not have any something like tension. If you have a string, there is a problem of tension. Tension might be 0. So you have to ensure that tension should be greater than 0. But in this case there is no problem of tension. So if you simply ensure that the velocity just after reaching there is 0, then you will get the answer. Are you getting on? So what is the sufficient criteria? I have to have the velocity here, just here, it will be 0. So I have to have, when theta is equals to pi, my omega will just be 0. That is the enough criteria. So you have the equation, and now put the value. We have equation for omega. The first equation you have written in terms of energy conservation. In that equation, you put theta is equals to 180 degree and omega is equals to, final omega is equals to 0. You will get the answer. Are you getting? So let me show you the first equation you have written already. So this is your energy conservation equation. This equation. Are you getting? The only thing is, now the 2GL by L, 2G by L, under root 2G by L, I will not have under root 2G by L. Here you see, you will have kg by L. So you simply put kg by L, you will get the answer. So you will put the kg by L, and then you will find omega here. So in the second case, omega just 0. So you will find, if you put the theta, you will find what is the relationship for the k. And if you have greater than that, so this means, so let us find first k. So should I do, or you can do this one? Okay, let us do this one. So I have the final equation. Let us give me this final equation. So I can write here potential energy. Okay, let me do this one. So energy conservation equation was something like this: half I and kg by L. So A, basically I is, okay, let me write something like this. Half I is what? 8 ml square into omega square, that is kg by L, plus 3 mgl. You see your notebook, you will find the same thing. 3 mgl. This is equals to, the energy is mg 2 mgl 1 minus cos theta. I am simply repeating. I am not doing anything. And plus 3 mg 2l minus l cos theta. Are you getting? What I have to do is, and you will also have a kinetic energy, half I omega square. This is the potential energy. Basically, if you want, you can just put half I omega square. So this is the potential. You see the previous page. Finally, I said, finally this omega becomes 0. Let us say at the vertical point, when this reaches here, that is this point, there is some omega, and the next we will put omega is equals to 0. So if there is a omega, you can say some energy is half I omega square. Now theta is pi, so cos theta is minus 1. So things become simple. So we will have 4 here, 4m, LL goes out, m z into k. So we will have 4m z k, and L goes out. So we will have 1L plus 3m zl. Are you getting? Is equals to, now we have 2m zl here and cos theta minus 1. So pi is equals to minus 1. If you put theta equals to pi, this is minus 1 minus minus plus. So we will have 4m zl plus, now again 2 to 3, 3, 3, 9. So we will have 3m zl. Are you getting? Plus half I omega square. So if you see, this becomes 9mgl plus 4, 13, and this 10. So I can write half I omega square is equals to 4mgkl, and this is minus 10mgl. Are you getting? So this is the expression for omega square. Now omega will be simply this is, so omega will be, omega square you can say 2 by I, this value 4mgkl minus, I am not putting the value of I because I does not need basically. Now I need this omega square should be greater than 0 if this reaches at to this point. So this means 4mgkl should be greater than 10mgl. Are you getting? So this mgl goes out, so I will have k should be greater than 5 by 2. That is the NF condition. Are you getting or not? If k is greater than 5 by 2, this will complete the vertical. Even if you have k is equals to 5 by 2, it will complete the circle, because if k is just equals to 5 by 2, it will reach to the vertical point. Are you getting or not? You just copy this one, and then we'll go for the next problem. So what we have said is, to reaching the vertical position, you should have just velocity, or even if you put the velocity as 0, you will get the idea. Are you getting? So at that point theta is equals to pi, so I can put the theta is equals to pi in this case, and then I can solve the equation easily. So in this question we have not done anything new. We have simply done the energy conservation equation, and this is basically a case of pure rotation. So this system is rotating purely about A, so I have to have moment of inertia about A, and I have to apply energy conservation, and in that case the pure rotational energy half I omega square I have to write about point A, because this system is in pure rotation about point A. You're getting? That is an important point. And now you have to also consider the center of mass of system. Separately, you have to consider the center of mass of rod, and you have to consider the B mass also. To find out the moment of inertia about A, you have to use the parallel axis theorem for the rod, that is we already know, that is about the ml square by 3. Now in this case m is different, m is different, l is different, so you have to put corresponding m and corresponding l, you will get the answer. I think all of you have written this one. Please do fast. Theta negative suggests me that the angle is greater than 90 degrees. That is the only hint I am getting. Okay, if somebody missing from the top, let us copy. And then we'll discuss the next problem. Theta minus 355 only says that the angle is not acute because cos theta negative, this has to be a second quadrant, and that's why I made the position of rod something like this. So in the previous case, first part of the question, theta will be 0, omega will be 0 only after it crosses the horizontal position. So rod will cross this position and then will be theta, omega will be 0. So this means in the first part, if the k is 2, this rod will go from here to here and then it will come return back. Are you getting? This is rod, and that's why again it will complete a circle. So in the returning journey also it will come along a circle because it does not have any choice. If you have a string, in that case, if the velocity is 0, it will follow a parabolic path in that case. But in this case it will come by a circle because this is a constant. Rod cannot be slacked. Rod has to have a fixed tension. Rod cannot slack, and that's why it can go by circle and it will come by circle again because you cannot break the rod. The rod cannot get tension 0, and that's why when I am applying just reaches the vertical position, I am not considering the tension. But if you have a string, in that case I have to consider the tension also. In that case the condition will be tension should be greater than 0. To complete the circle, if you have a string, in that case tension should be greater than 0 should be the criteria. If you have a rod, in that case, that the velocity at this point is just greater than 0, that the velocity is greater than 0 will be the criteria. If you do the same question, if you have remember the vertical circle completion, if you do the same question, you have a ball, and if you throw this with velocity v, so that is complete the circle, if you find this comes out to under root 5 gl. But if you take the rod, it will come under root 4 gl. So you do the same thing, because in the string the condition is tension should be greater than 0. In case of rod, let us say the massless rod is there. In case of rod, you will find this has simply at this point this has to has a 0 velocity. That's the enough condition. So if you have rod, the condition will be v is greater than 0. If you have a string, then you have a condition t is greater than 0, because in a string there is a chance that a string can lose its tension, and that becomes critical, and that's why we are considering the tension. So if you have a string, tension becomes important, tension becomes critical. This means velocity is not critical. Velocity is critical when you have rod. Let us copy this one and then we'll discuss. Sometime we'll discuss this also, this problem also, maybe in the class itself. If you have copied this one, let us go for the next problem.